Today we are going to do a beam design. Let us assume MU or ultimate moment or design moment is 50 kilonewton meter. We have to find beam cross section and the amount of reinforcement. This is a typical cross section. Capital B is width of beam, capital D is total depth, small d is effective depth. AST, that is tension reinforcement, that we have to find. See, let's find out the difference between capital D and small d, that is total depth and effective depth. Capital D, that is total depth, is the distance from top fiber to the bottom fiber of a cross section of a beam. Small d, that is effective depth, is the distance from top fiber to the center of reinforcement. Similarly, cover, it's the distance from center of reinforcement to the bottom of fiber. Our calculations are solely depend on this small d, that is effective depth. So we have to find what is effective depth, what is this value. We can get effective depth by dividing span by 12. In our case, let's assume span as 3800 mm divided by 12. We get this value 316.67. Upon adding cover, we get total depth as 341.67 mm. Let's round off this value to 350 mm, and so we get the dimensions of the beam, which is width is 230 mm, that you already assumed as the wall thickness, and capital D, that is total depth, is 350 mm. And to find the effective depth, we subtract cover from the total depth, we get 325 mm. This is the value we are going to use in further calculations. Now amount of reinforcement that we need to calculate. For that, we assume concrete grade as M20 and reinforcement grade as Fe500. We are using IS 456-2000 code, and all our calculations are based on this code. Steps, these are the steps, two steps which we need to follow. First, we have to find the limiting moment, that is M limiting. And second step, if this M limiting is greater than M design moment that we assumed as 50 kilonewton meter, then the beam will be designed as singly reinforced. Or if M limiting is lesser than design moment, then the beam will be designed as double reinforced beam. First of all, what we will do, we will follow our steps. We will find the M limiting. To find the M limiting, we have this formula in page 70 of IS 456-2000. Here we have got some variables like XU max, that we are unknown. What is its value, we have to find out. D, that is effective depth. B is width. FCK, that is concrete grade. We have assumed as 20 Newton per mm square. Now if we go to page 70 of the same code, for Fe500, we will get this value, XU max equal to 0.460. Now we are going to substitute this XU max 0.460 in this formula. After substituting 0.460, we will get this expression for Fe500. Similarly, for Fe415, we will get 0.138 FCK BD square. For the time being, we are using this formula 0.133 FCK BD square. After substituting the value of FCK, B and D, that is 20, 230 and 325 respectively, we get 64.6 kilonewton meter, that is greater than 50 kilonewton meter, that is design moment. So our M limiting is greater, means it has enough capacity. So we are designing the beam as single reinforced beam, that is the beam will be at the bottom only. Now after we have decided that the beam is singly reinforced, we need to find what is the value of AST, that is what is the value of reinforcement. We have got another formula at page 96 of the same code. We go to clause G 1.1b. Here is the formula. MU, that is design moment, it is 50 kilonewton meter equal to 50 into 10 to the power 6 Newton mm. Here the units that we are using that are all in Newton and mm. And so now coming to this equation, MU, that is 50 kN meter, it is 50 into 10 to the power 6 into mm. Fy, grade of steel is 500 Newton per mm square. AST, that we have to find out. Small d, that is effective depth, it is 325. B is width of beam, that is 230 mm. FCK, that is grade of concrete, is 20 Newton per mm square. Upon substituting all these values, we solve for AST, and that comes out to be 410 mm square. But this calculation is not enough. We have to compare this AST value with the minimum reinforcement required in any beam. We again go to page 47 of the same code, clause 26.5.1.1. give this formula: 0.85 BD by Fy. B is width of beam, D is effective depth, Fy is reinforcement grade, that is 500. Upon substituting all these variables, we get 127 mm square as AST minimum, which is far lesser than the reinforcement that we got. So our final reinforcement is 410 mm square. We assume the diameter of bar as 12 mm. Area of one 12 mm bar is 130 mm square. Therefore, number of bars equal to 410 divided by area of 112.5 bar, that is 113. We get the number of bars as 3.62. We round off the given value to 4 numbers and we place at the bottom of the beam like this: 1 2 3 4 12 mm bars. Width of the beam is 230 mm and depth of the beam, total depth, is 350 mm. This is our beam design. This is singly reinforced beam. Now in the next section we will design the beam as doubly reinforced beam. Thank you.